Hello GCC chemistry students. Welcome to Lewis dot structure number 3 with Dr. Kim. We're going to draw the Lewis dot structure for HCN and the C is underlined. Let's remind us of our steps. First we're going to count the valence electrons. Then we're going to put the center atom in the middle and draw single bonds to the rest of the atoms. Everybody needs to have 8 electrons in the final drawing, except hydrogen only needs 2. And then we need to check that the total number of electrons in the drawing equals the number of valence electrons we added up in step 1. So we have HCN, and our first step is to add up the valence electrons. How many valence electrons does hydrogen have? Well, hydrogen being the first element, number 1, only has 1. So 1 electron for hydrogen. Carbon. Carbon is in that tricky fourth column. So, column 4A, how many valence electrons? You're correct if you said 4. And then nitrogen's right next door in column 5, which means it has 5 valence electrons. So we have 1 plus 4 is 5 plus 5 makes 10 total. Now, let's draw the structure, putting the center atom in the middle, which is the C, and drawing single bonds to the other atoms. So we have an H and we have an N. Now, we need to have everybody with 8, except the hydrogen only needs 2. You may wonder, why does hydrogen only need 2? Well, hydrogen's closest noble gas is helium, which only has 2 electrons. So hydrogen wants to be like helium with only 2 electrons. Everybody else that's a nonmetal wants to be like their nearest noble gas. And starting with neon on down, they have 8 outer electrons in their s and p orbitals. So hydrogen just needs 2. How many does hydrogen have right now around it? Well, it has a single bond to it, and a single bond is 2 electrons, so it's done. Hydrogen already has 2, it is done. Let's look at the nitrogen. It has a single bond around it, which is 2, so it needs 6 more. 1, 2, 3, 4, 5, 6. Carbon. Carbon has 2 bonds around it, which is 4, so it needs 4 more. 1, 2, 3, 4. Now, if you remember, our last step is to check that our electrons in the picture equals what we added up in number 1. Let's count our valence electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh my, that doesn't equal 10. So this is incorrect. Single bonds did not work. What do we do if single bonds don't work? You're correct if you say, start over, and this time try a double bond. Now we can only do 1 double bond. Will we double bond to hydrogen? Well, that would make 2 bonds to hydrogen, 4 electrons. Hydrogen would have 4 electrons, and hydrogen only needs 2. So the double bond can't be to hydrogen, so we're going to try the 1 to nitrogen. And we're going to play the game again where everybody needs 8 except hydrogen needs 2 and see if the single-double combination works. All right, hydrogen needs 2. It already has 2. It has a single bond. Nitrogen needs 8. It has 2 bonds, 4 electrons. It needs 4 more. Carbon has 6 bonds to it, a double and a single, which makes 6 electrons. So it only needs 2 more. Okay, everybody has 8, but hydrogen has 2. Let's count the total number of electrons again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 is not 10. That did not work. Now, normally we would double the other bond, but we've already said we can't double a bond to a hydrogen. So what can we do now? Well, we can try a triple bond to our nitrogen. So let's draw this one more time. Trying a triple bond to the nitrogen. Again, we're going to play the game where everybody needs 8, but hydrogen needs 2, and then check. Hydrogen, again, has 2. It is done. Nitrogen has 1, 2, 3, 4, 5, 6. 6 electrons to it. Needs 2 more. Carbon has 1, 2, 3, 4, 5, 6, 7, 8. Carbon already has 8. So don't put any dots on carbon. It already has 8. It's done. So we're done. Everybody has 8 again. Let's check one more time for total electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 10. It was a single triple combination that worked. This is our correct Lewis dot structure for HCN.